Hi guys, so we're going to be working on solving linear equations, which is a review from Algebra 1. Also, you did a lot of that in geometry. So the big things when you're solving an equation is the first thing you want to do is make sure that you're applying the distributive property, or we're going to talk about a fraction bust, which is when you cancel out the fractions. We want to clean up or combine all of the like terms on either side of the equation. So if you have any like terms on one side, you want to make sure you simplify that first. The next step is going to be isolate your variable. So you want to get your variable alone on just one side of the equation. Some people always like to get it on the left. Some people just go on whichever side that you have a positive for your variable. And then you start undoing your order of operations. So that's where you do the inverse function. So the opposite of add would be subtract, or the opposite of multiply would be divide. And then the fifth is you're going to check your answer. So you want to substitute your answer back into the original equation and you check to see are both sides balanced. Okay, so now we're going to solve our first equation. So we're going to look at number 1. Some people like to draw a line right down the middle of the equal sign so they can see the two sides of their equation. The first thing I would want to do is look and see, do I have any distributive property that I would need to do? And I don't. So I don't have any fractions that I want to be able to get rid of, so I'm not going to do that. So the next step, do we have any like terms on either side? No, we don't. So now I'm going to try to isolate my variable. So I'm going to get it alone on one side. So I notice the only place I have a variable here is my 4n. So that's what I want to try to get all alone. So I'm looking at my minus 10. How do I cancel out a minus 10? The inverse operation is add. So I'm going to add 10 to both sides of the equation. So now we're going to cancel out on the right side over here, and we can bring down our 4n, and then we have our 12 plus 10, which gives us 22. So I still bring down my equal sign. So now I have 4n equals 22. So I still have to isolate my variable, so I'm trying to get my n all alone. So in order to undo times 4, because if I'm looking at this, let me change my color here, we can see if it says 4n, it really means 4 times n. So if I'm trying to get my n all alone to undo the times 4, we're going to divide both sides by 4. This is where some people start to get upset because they looked at this 22 divided by 4. 4 doesn't go into 22 evenly. But if I'm looking at 22 fourths, they are both divisible by 2. So if I divide 22 by 2 and 4 by 2, I end up with 11 over 2. I know some of us don't like fractions. We got to get used to them. Some people might have also just put it as a decimal, 5.5. So that's also correct. We do want to start practicing with fractions. We're going to see them coming up a lot more often in Algebra 2. So now I'm going to check my work. So I have 12 equals 4, and now we're going to insert our 11 halves minus 10. So to do this, I'm going to multiply 4 times 11 halves. Anytime I'm multiplying and I have a fraction, I can always rewrite any constant as over 1, and now I can just multiply straight across. So we can do the 4 times 11 is 44, 1 times 2 is 2. Bring everything else down, 12 equals 44 over 2 minus 10. Well, what is half of 44? Half of 44 is 22, so we have 12 equals 22 minus 10. And does this check out? Are both sides balanced? On the left we still have 12, and on the right 22 minus 10 is also 12. So that tells us that the equation's balanced. Okay, so looking at number 2, so on this one there's no distributive property of fractions. We don't have to clean up or combine like terms on both sides of the equations, but we do notice that we have variables on both sides. So I have to isolate my variable. I figure out which side I want to get my variables on. Because I have a negative 4c over here, I want to cancel out this negative 4c so I can add 4c to both sides. So negative 4c plus 4c cancels out. 2c plus 4c is 6c. I still have my plus 14. I still have my equals, and I bring down my 6. So now that I've decided my c's are going to be on the left, I need to get all my constants to the right. So if I have plus 14, the inverse of adding 14 is subtracting 14. So those are additive inverses of each other. So I cancel out 14 minus 14. I bring down my 6c, bring down my equal sign, and 6 minus 14 is negative 8. So again, still trying to get my c all alone, my variable all alone. How do I undo a times 6? Because this is really saying 6 times c, is I divide both sides by 6. So I end up with c equals, and again notice, I know we don't like them, but it's a fraction, right? So I always want to look at my fractions, think, can I simplify this? So let's see, these are both divisible by 2. So negative 8 divided by 2 is negative 4. 6 divided by 2 is 3. So we end up with c equals negative 4/3. For number 3, we notice that now we have some parentheses. So we are going to have to start by applying our distributive property. So we're going to distribute our 3 to both terms. I'm also going to distribute my negative 2 to both terms. Notice here there's that minus sign in front of the 2. Some people right away like to change this to plus negative. So now as I distribute, 3 times 2a is 6a, 3 times 25 is 75, and so now I'm going to distribute my negative 2. So negative 2 times a is negative 2a, so I can write it as minus 2a, and then negative 2 times negative 1 is positive 2, and I bring down my equals 78. So the first step is to apply the distributive property. The second step, if we remember, up above where we have all our steps, says clean up or combine like terms. So if I notice on the left side, I have 6a and I have negative 2a. So those are like terms. And then I also have my 75 and my 2. So those are like terms because they're just constant numbers. So now we're just going to combine our like terms. So 6a and negative 2a, 6 minus 2 is 4, so we have 4a. And then we have 75 plus 2, which would be 77. And we have it all set equal to 78. So now again, my next step is going to be isolate my variable. So I want to get it alone on one side. So if I notice over here, my 4a is on the left. There's no other a's anywhere. So I need to get rid of this plus 77. So what's the inverse of adding 77? We can subtract 77 on both sides of the equation. And then I bring everything else down. So I have my 4a equals, and 78 minus 77 is 1. So now, again, I look at this. 4a really means 4 times a. So how do I undo times 4? I divide by 4. So we end up with a equals 1/4. Again, fractions are okay to have as answers. Okay, so looking at number 4, for number 4, what's going to be our first step here? Good, so on this one, we're going to again have to start by distributing. So I'm going to distribute my 12. So 12 times r is 12r. 12 times 3 is 36. Over on the right side of the equation, I'm going to have to distribute my 2. So we have 2 times r is 2r, plus 2 times 5 is 10, and I still have my minus 3r. So first step, apply distributive property. Second step, clean it up, so combine the like terms on either side. There's no like terms on the left, but what I do notice is that I do have some like terms over here on the right. So now I'm just going to rewrite. We have our 12r plus 36 equals 2r minus 3r is just negative 1r, and I still have my plus 10. So now I've combined my like terms, so now I have to isolate my variable. So I have positive r's on the left, I have negative r's on the right. So I'm going to cancel out my negative r by adding an r, because negative r plus r will cancel. So if I do that on the right, I have to do it on the left. 12r plus 1r is 13r. So 13r plus 36 equals 10. So now I've gotten all of my variables on one side, so I've isolated my variable right here. So now I need to move my 36. So if I have plus 36, I can cancel out adding 36 by doing the inverse, subtracting 36. So I'm going to do that on both sides of my equation. 10 minus 36. So when I have different signs, it's kind of like saying 10 plus negative 36. I would subtract them. So 36 minus 10 is 26, and then I keep the sign of the one with the bigger absolute value. So I keep that negative sign, and on the left I have 13r. So now my last step to isolate my variable, this is like saying r times 13, so to undo times 13, we divide by 13. And this one actually comes out nice. When I divide 26 by 13, I get 2. And then I also have to pay attention, I'd had this negative sign right here, so a negative divided by positive is a negative. So we end up with r equals negative 2. Okay, so number 5, we have a fraction, we have a negative, so you know that's not always fun. One of the things I do when I have fractions and I have a negative sign is I rewrite this. I put this as negative 3/4 because I want to make sure that I only use that negative sign once. So this is negative 3/4. So now, how do I cancel this out? I'm going to show you 2 ways, because you might have done it 2 ways in the past. The first way and the most efficient way is just by multiplying by the reciprocal. So what's the reciprocal of 3/4? The reciprocal would be 4/3. In this case, though, we have negative 3/4, so it's going to be negative 4/3. So I can multiply both sides by negative 4/3. The reason we're doing this is when you multiply by a reciprocal, it equals 1. So we want the coefficient of x to be 1. If I multiply straight across, I can see negative 4 times negative 3 is positive 12. 3 times 4 is also positive 12. Well, what's 12 divided by 12? It's just 1, so it all just cancels out. I still have that x, so I have just my 1x equals, and then on the right side, I could rewrite this as 15 over 1, and again, I can multiply straight across. 15 times negative 4 is negative 60, and 1 times 3 is 3. So here I end up with x equals negative 20. So again, that's one way to do it. I don't like having to do as many steps. I'm someone that likes to cross cancel. So I'm not sure about you guys and if you spent time doing this, but you might notice that right up here, so we're going back up to the top, right up here, if I have a 3 divided by a 3, 3 divided by 3 is 1. If I have 4 divided by 4, I can cross cancel those. 4 over 4 is also 1. And I can also notice my negative times a negative is a positive. So I can get straight to this x. So I have x equals, and now on the right side, I can also cross cancel. Instead of multiplying out 15 times negative 4 and getting a really big number, I can notice I can cross cancel right here. My 15 divided by 3 is 5. So now I just have 5 times 4, which is negative 20. So whichever way works better for you, you're welcome to do. So that's one way to solve all of this. If this was tricky, if you've never talked about multiplying by reciprocals before, I'm going to do it another way. Okay, so the other way to do it, again, I'm still going back to rewriting this as negative 3/4. Again, I don't like to put my negative sign out in front because I want to make sure I don't forget about it. So some people like to just get rid of that fraction in the denominator, right away. So if I see, okay, I have a 4 in my denominator, I can undo this whole dividing by 4 by just multiplying by 4. So I can multiply by 4 on both sides. So there we go. We've just canceled out our denominator. What am I left with? Negative 3x. And on the right, 15 times 4 is 60. And then from there, I can divide both sides by 3. Negative 3. So we end up with x equals negative 20. So we got the same answer. So if fractions confuse you, you might want to go with this method of just find what your denominator is. Technically, what a denominator or fraction is saying is divided by. So if you're dividing by 4, do the opposite. Multiply by 4. Okay, so we're looking at number 6 now. So for number 6, we don't have any distributive property. We don't have too many fractions. We do have a little bit of a fraction. But what I want to first do is isolate my variable because there were no like terms on either side. So if I'm trying to isolate my variable here, what I do notice is that my 4x is connected to my 7 because it's 4x over 7. So that's what I want to try to get all alone first. That's what I'm trying to isolate. So to cancel out my plus 2, I can subtract 2 from both sides. So now on the left side, we have negative 6 and a negative 2 because minus 2 is the same thing as a negative 2. So that gives me negative 8. And on the right side, if we have our 4x over 7, now I can actually start to isolate my variable. So this is saying 4x divided by 7. So the inverse of divide is multiply. So I'm going to multiply both sides by 7. So 7 times negative 8 will just give us negative 56. And my 7 over 7 canceled right there, so I'm left with 4x. So now in order to get my x all alone, what I can do is divide both sides by 4. So 56 divided by 4 equals negative 14. Okay, so as we turn the page, now we see the not nice problems, right? So we have these fractions. So this is where the whole fraction bust comes in that we've talked about. And with a fraction bust, what you want to look for is the LCM, or another word for that is the least common multiple. So we're going to do a fraction bust. So we need to find that least common multiple because we want to be able to cancel out our denominators. So if I'm looking at 1/2 and 1/3, I'm looking at the 2 and 3. And what number do 2 and 3 both go into? They both go into 6. So I can multiply this side of the equation all by 6. Anytime I'm solving equations, if I multiply the left side by something, I also have to multiply the right side by that. So as I start to now distribute my 6, I'm going to say 6 times 1/2. Well, what's half of 6? Half of 6 is 3, so I'm left with a 3y. And then I have 6 times 1/3, which is 2. So I have plus 2y equals 60. If you're wondering how did I get that 3y and 2y, so I'm just going to set this up down below just so we can kind of see where that comes from. If I had 6 times 1/2, when we multiply with fractions, that's where we multiply straight across. 6 I can rewrite as 6 over 1. 6 times 1 is 6. 1 times 2 is 2. And 6 divided by 2 is 3. So that's where this 3y came from. If I had my 6 times my 1/3, again, when I'm multiplying with fractions, rewrite the 6 as over 1, and then we multiply straight across. So 6 times 1 is 6, 1 times 3 is 3, and 6 divided by 3 is 2. So that's where my 2y came from. Or if you're comfortable, what I really like is my cross canceling, because as soon as I see this 6 over 2, I know that simplifies. 6 divided by 2 is 3, and 3 times 1 is 3. Boom, done. Over here again, I can cross simplify here. 6 divided by 3 is 2, and 2 times 1 is 2. Again, done. So that can be a quicker way to do those. So let's get back to solving these equations. Notice we do have like terms that I can combine. So I have my 3y and my 2y. So when I add 3y plus 2y, I get 5y equals 60. And so now I can go about solving 5 times y. So to undo times 5, we divide both sides by 5. And 60 divided by 5 is 12. So looking at number 8, notice I have all of these denominators. I have 5, I have 6, I have 10, and I have 3. So I'm trying to figure out what number do they each go into. I'm going to start with the 10. I know 10, we have 10, 20, 30. So now I'm going to look at my 5 and 6. I know with 5s, I can count by 5, 5, 10, 15, 20, 25, 30. So 5 goes into all of those. If I look at 6, if I'm counting by 6s, we have 6, 12, 18, 24, 30. So again, notice 30 keeps coming up, and then 3 also goes into 30. So 30 is going to be our least common multiple here. So since all these numbers go nicely into 30, I'm going to multiply both sides of my equation by 30. Because when I multiply 2 times 30, I get 60, and 60 divided by 5, so as I'm distributing here, 60 divided by 5 we know is 12, so we get 12k. Then I'm going to multiply this by 30. 30 times 1 is 30, and 30 divided by 6 is 5. And I'm going to distribute my 30 this way. So 30 times 3 is 90, and 90 divided by 10 is 9, so we have 9k. And I'm going to multiply here. 30 times 1 is 30, and 30 divided by 3 is 10. So now I have variables on both sides, so I have to decide which side I want my k's on. I'm going to go for my k's on the left, because if I subtract 9k from this side, I know it'll cancel. And when I subtract 9k over here, I end up with a positive, so that makes me happy. So I have 3k plus 5 equals 10. Now I want to get my k all alone, so I can cancel my plus 5 by subtracting 5. So I have 3k equals 5, and my last step is divide both sides by 3. So notice this definitely wasn't as scary as it originally looked, because we were able to cancel out all of those fractions. That would not have been fun to do with fractions. Okay, we're almost there. Hang in there. So if we're looking at number 9, now we're dealing with some special cases. So for these special cases, again, my first step, I'm still going to go about them the same way. I'm going to distribute. So I have 5x minus 20 equals 5x plus 12. So now my next step is to get all my variables on one side. So I have to isolate my variable. So let's move this 5x on the right to the left. So I'm going to do a minus 5x so I can cancel out this 5x. And I'm going to do the same thing over here, right? Whatever I do to one side, I have to do the other side, except for what happens here. So this 5x cancels out as well. So now I'm left with negative 20 equals 12. Is that a true statement? Is negative 20 equal to 12? No, it is not. It's not equal to 12, so I put a slash through my equal sign. Negative 20 is not equal to 12, so that's a false statement, which means this one has no solution. So if your variables cancel and the sides are not balanced, it's no solution. So what happens if they cancel and the sides are balanced? Do we remember what that might be? So let's look at number 10 to find out. Let's see if that one has both sides balanced. So let's start off. We're going to distribute our 5. So we have 10 minus 5x equals, and on the right side, before I even write all of this down, I'm just going to start by combining like terms. So I see I have those x's, and then I have these constants. So negative 2x and negative 3x gives me negative 5x, and 3 and 7 give me 10. Okay, so now I want all my x's on one side. So let's cancel out our negative 5x on the right. How do we do that? The opposite of negative 5x is positive 5x, or its inverse. So I can add 5x to the right, which means I also have to add 5x to the left, because we always have to keep everything balanced. They cancel out on both sides here, and now I'm left with a 10 up here that I can bring down my equal sign, and I can bring down this 10. So I get 10 equals 10. So 10 equals 10 is actually a true statement, right? Because 10 is equal to itself. So that's a true statement, which means all real numbers, or you could say infinitely many solutions. So some people say IMS for infinitely many solutions, although write infinite or infinity. So you have an infinite number of solutions here, or all real numbers. Great job hanging in there. We're almost done. This is the last one, I promise. So to start off with, first step is always what? We always want to see if there's any distributive property, and there is. So we can start by distributing. 2 times x is 2x, plus 2 times 4 is 8. On the right side, there's nothing to simplify, so I'm just going to bring down what we have. So now I want to move all my x's to one side, so let's get rid of these negatives. So I'm going to cancel out my negative 3x by doing its inverse operation. So I'm going to add 3x to both sides, because negative 3x plus 3x cancels. So I'm going to add 3x to this side. 2x plus 3x is 5x. So we have 5x plus 8 equals, and I have my 8 on this side. So now I've isolated, or almost isolated, my variables, because I've moved my x's to the left, which means all of my constants need to be moved to the right. So to cancel out a plus 8, we're going to subtract 8 on both sides. So I notice on the left, the 8 cancels out like I want it to, but then on the right, it also cancels out. This is what will usually throw people off, because they say 5x equals, and then they don't write anything in here, and then they think, oh, it's a no solution. But what's 8 minus 8? 8 minus 8 is 0. So we're not saying no solution yet. Now I'm trying to get my x all alone. Well, how do I cancel out my times 5? Because this is technically saying 5 times x, right? So to undo times 5, we divide by 5. Can we do 0 divided by 5? So what I always say is that it is okay to do 0 divided by a number. It just equals 0. But it's a big NO to divide by 0. That's when you have no solution. So here we're doing 0 divided by a number, so my answer is just 0. So this is not a no solution. You're allowed to get x equals 0 as a solution. All right, you made it through. Great job, guys.